Hi Dinisha, you further proceed, ma'am.
Good morning to everyone present here. Sorry, some network issue. It's my great privilege to welcome you all for this webinar. Drone deployed 3D imaging systems. First, I would like to welcome our Managing Trustee, Dr. P. Krishnadas sir, and CEO and Secretary, Dr. P. Krishna Kumar sir, Nehru Group of Institutions, who are true leaders and transforms every vision into successful reality. I welcome them in their absence. Next, I would like to welcome Dr. M. Sivaraja, Principal, NIT, whose constant guidance and support has always inspired us. Now, with most respect, I would like to welcome our chief guest, Mr. Praveen Vishnathan, Business Development Manager and Senior Drone Pilot Instructor. Next, our second chief guest, Mr. Abhilash, Drone Pilot Instructor. Welcome, sir. I would like to welcome the HODs from various other departments. Also, my dear fellow colleagues, I'm very happy to welcome you all. Last but not least, I welcome all my dear students. Welcome you once again. Thank you.
Thank you, ma'am. Leadership is not a title or designation. It is an action and example. I extremely privileged to invite Dr. M. Sivaraja, sir, Principal, Nehru Institute of Technology, to express your presidential address, sir.
Yeah, thank you so much. It's a great pleasure to propose this presidential address in this auspicious occasion. First, I'd like to appreciate the efforts of Department of Aeronautical Engineering and the Center for Geospatial and UAV Technology Research for organizing today's webinar in association with JMA. And my sincere thanks and welcome to the JMA people and the guest speakers and chief guests to this webinar. Actually, our Center for Research and Innovation is actively conducting a lot of initiatives. One of the centers in our research and innovation is Center for Geospatial and UAV Technology Research. So already we have started many things in the research and development area. The purpose of having this research centers to give the exposure to the faculty members and students related to the particular upcoming technology, and then creating the research culture and innovation culture in the campus. So this is the idea. So it's a first initiative which is taken by the Center for Geospatial and UAV Technologies in association with the JMA. Today they have organized. So it is a very happy news from the Department of Aeronautical Engineering. So I sincerely request faculty members and students of aeronautical engineering to participate in this webinar, and the thing should not stop in this webinar itself. So we have to do a lot of things. You have to create your own drones, and you have to do some research works on this drone development and 3D imaging systems, etc. So this is the expectation from the management, our trustee, Dr. Krishnadas sir, and our CEO and secretary, Dr. Krishna Kumar sir, and our management team. And my expectation is it should not be conducted as just like as a webinar. So you should, we are expecting an outcome out of this webinar, and then you should go to the next level. You should motivate the faculty members and students to enter into this area and do some innovative works in that particular drone development and 3D imaging system. This is my expectation. I request Department of Aeronautical Engineering to take severe steps to attain this objective. Once again, I really thank JMA people for joining with us. Your support is most welcome for us. So without the support of industry, nowadays the institution cannot grow. So we are very much interested to have the MOUs or whatever it may be, some collaboration, research collaborations in association with the industries, particularly with the JMA. You are a very reputed industry in this drone development. So we are very happy to associate with you in all aspects, not only in the research as well as the innovation side or incubation side. So whatever the possibilities are available, please help us in collaborating with all the activities, and JMA and NIT should go in a longer way, and we should grow each other. So that is the objective of our Nehru Institute of Technology. Thank you so much for joining with us, JME. Also, I appreciate the efforts taken by Department of Aeronautical Engineering and Center for UAV Technologies and Research. Thanks for the opportunity. Thank you.
Thank you, sir. Thank you. We will definitely collaborate and we will work forward.
Thank you so much, sir. Thank you.
Thank you, sir. Being the captain is a great privilege and responsibility to lead a great group with different cultures. I invite Leo Peter Charles, founder and managing director at JMA Aerospace, Bangalore. Instead of his busy schedule, he is unable to join today, so I invite Mr. Praveen Vishwanath, Business Development Manager and Senior Drone Pilot Instructor, and Mr. Abhilesh, a Drone Pilot Instructor.
Thank you, Ms. Syed Uniza, for this wonderful greetings that you have given us. And
Thank you.
yeah, so we will get started with this, and a warm welcome to everyone. Good morning to everyone. And we are going on a new chapter called 3D imaging systems using drones. So this is a very vast industry that we are looking here in India, and it is one of the top two in applications here in India that we are using drones for. And majorly it is led by the agriculture and the mapping division. And we see a phenomenal interest by the government being invested in this segment. We have the Survey of India and the Archaeological Department of India working tirelessly using drones for 3D mapping as well as for other survey related matters. So the government of India has released latest is the Samvitva program, which is focused basically on working on drones, using the drones to get the entire mapping data for the people of India, who have majorly the outcome is to reduce the land disputes in India and to get an accurate data of how much the land is owned by Indian and India basically, and drones are intensively used for that. And when it comes to village section, the drones are widely used there to map the agriculture fields and respectively show the survey ID numbers and to give the exact data as to how much is land belongs to each farmer, and thus reducing the land disputes, because this is one of the major problem that has been faced in the industry. So using drones, they are able to overcome this entire segment. And 3D imaging is a wonderful technology that has been out in the industry right now. Using drones, it is very much capable of even mapping the largest structures in Earth. So without any further ado, we'll get on to the topic today. And next slide, please. So the actually, Mr. Leo Peter Charles, the founder and the CEO of Aerospace, was supposed to have the webinar today, but unfortunately, due to his very busy schedule, he's been tied up at a meeting right now, and he's not able to come. And we wish it was possible by him, but due to all these circumstances, he is unable to join us today. But anyway, so let's go ahead. Mr. Leo Peter Charles is the driving force of JMA. With all his visionary acts and his idea has been pushing forward and making us go across this entire boundaries. And we are able to be so motivated and work in this environment. And moreover, drones are the future, what we strongly believe in. And it is one of the segment in the Industrial Revolution 4.0. So totally right now, more than 37 industries or the segments are using drones in vast applications. So when we say applications, the application is mounting to more than 230 plus applications are used by these 37 such industries. So since the drone segment is growing very rapidly here in India, the exposure to the drone segment is very large. It is very promising, as well as the data that is being acquired is so dead accurate. And when it comes to mapping, we are getting accuracies less than 1 centimeter, or even in some cases, we also get less than 2 mm. So that is how accurate the data that we are receiving. So without any further ado, we'll be proceeding with the major part. So we'll have a general introduction right now about drones. So people who are aware and not aware about drones, so they can get a slight idea as to how it goes forward. So this is the topics that we will be discussing in today's webinar, and we will start up with the introduction to drone segment. So drones, when we say the word drone, we are idealized, or we only get to understand an object that is flying in the air. So this is a very basic understanding about a drone, but drone doesn't end there. So drone also is also used in water, underwater, on road. So on the ground, that is basically. So we call them as the ones that is flying above, we call them as UAVs. The ones that are there on the ground, we call them UGVs, or unmanned ground vehicles. Ones that are on the surface or under the surface, we call them respectively as submarines and ships or boats or RC boats or some those are the terminologies that are used. So we are in the segment, JMA works on a segment of UAVs, that is the unmanned aerial vehicle. So an aerial vehicle that is in the air and it is not being piloted by a human, but remotely piloted by a human. So that is what is the definition of a drone or an unmanned aerial aircraft. So how does drone work? So drone is actually split into three segments basically, and the three segments is the vehicle that is flying in the air, and the communication link between the aerial vehicle and the transmission data, and we have the ground control station. So these are the three important what do you say, the features that are used in the UAV segment. And the ground control station is the base station where basically all the inputs or the outputs of all the data in receiving, transmission, and collection of data happens. And we have the transmission media, that is where the link between the ground control station and the UAV happens. And the UAV as a whole is the one which carries out the missions depending on the payloads. So this is a very drone is a very like a synonymous to the entire segment, which actually classifies, and most of them mistake that saying drone as a UAV, but drones are also the ground vehicles and the submarines and the surface vehicles. So next slide, please. So drones are further classified in the air segment as fixed wing. We have the single rotor, we have the multi-rotor, we have the hybrid VTOL, we have the ornithocopter, we have the aerostat. So these are the six segments that we have in the UAV segment. We'll talk about the fixed wing. So fixed wing is a aircraft which looks like the real aircraft, but in a smaller scale, and it is powered by either a battery or a fuel-based system. And fixed wing, the advantage with a fixed wing is that it can have a long endurance, as well as it can have a very high altitude operations. And since due to its nature of having high endurance, it's widely used in mapping, and it's also used for search and rescue, and it is also used in other places of identifying fire hotspots. It's used in wildlife for monitoring animals so that they can avoid poaching and all of those. So it's a very wide application it has, but it lacks in certain places where the single rotor or the multi-rotor comes into play. So when it comes to a single rotor, it is basically a heli. So the heli is like an helicopter, which is in a scaled down version, which is either powered by an fuel-based system or based on a battery power, and it has a single propulsion system. And to compensate, it is very highly agile. The single rotor is very highly agile, and it can reach into very long distances, just like a fixed wing. But the advantage the single rotor has is it can hover in a single place. So that is the major advantage it has when compared to a fixed wing. When we compare single rotor and a multi-rotor, the multi-rotor has four propulsion system or six propulsion system or eight propulsion system, and it is more due to which it can be in a small size and carry a large payload. But when compared to an heli, the heli is quite large and it can carry a limited amount of payload. So that is the advantage and the disadvantage of a multi-rotor and a single rotor. So the multi-rotor has wide applications for mapping, and since it's able to hover in a single place in a very sturdy manner, it can also do 3D mapping of an object or a place. And it is highly used in the agriculture division as well. And for industrial testing like NDT testing, non-destructive testings, and quite more. Even in firefighting in buildings, very large buildings, multi-rotors are used because of its payload lifting capacity. So it has a very high usage, but still it is limited with its endurance and its range of flying. So that is where we have come with a hybrid version. It's called as hybrid VTOL. It can vertically take off and land. So it is a hybrid, it is a combination of a fixed wing and a multi-rotor. So due to which you are able to get high endurance, as well as it can hover in a single place and get access to data and control and communicate information, and it can also aid in transportation larger payload. So when we come to an ornithocopter, the bird that you see is actually this entire flight or the system is like mimicking a bird. So the one that you see right now is an bird which is used in Heathrow Airport in London, which is actually the entire this ornithocopter resembles to an predatory bird, which will scare away the smaller birds so that they do not have any airstrike, bird strike in the airport, or have any other damages to the aircrafts in the airfield. So they use ornithocopters. One of the reason is they can avoid using live animals because training live animals and keeping them and upkeeping them is very really tasking. So ornithocopters are widely used. If you remember a movie called as Yuri, which is actually a terrorist movie wherein how the Indian army went through all the surgical strike and they won over the entire place. So they use this ornithocopter to spy on them, on their activities. So that is a major advantage that they have. So ornithocopter mimics just like a bird. So the aerostat is actually a gas-filled air balloon or airship, and here it is remotely piloted. So the advantage is it is able to be suspended for long hours for a very prolonged period with minimal use of energy. And aerostats are used largely for monitoring weather and related weather forecast and weather related to different locations to identify and detect different gases and in the atmosphere to monitor ozone layers. So it has a very wide application for prolonged period of monitoring. So aerostat is either fueled by battery or by fuel, and it is filled by either helium or hydrogen. So it is largely by helium-based systems. So we'll go to the next slide. So now I hand over the session to Mr. Abhitash, and if you have any further questions during the Q&A session, we will have the questions.
Thank you, Mr. Praveen. So we'll dive right into it. We'll talk about 3D mapping and imaging. So basically, right, as Mr. Praveen said, in India, especially throughout the world and even in India, mapping is a sector that is booming like anything. And 3D mapping and imaging is a sub sector in that. And what is 3D mapping and imaging? 3D mapping and imaging, it's basically a science of making measurements from photographs. The output you get will be either processed in a photogrammetry software or you get direct 3D point cloud outputs. These outputs are taken from the drones, aircrafts, even handheld devices from aerially, or you can do it in the land as well using different types of drones or even handled, like I said. So how it's done, we'll have a look at it and how the process is going throughout the country, in the industry, and how even individuals do it. Let's have a look at it. Okay, so a drone-based 3D mapping and imaging involves capturing of aerial data through downward-facing sensors. So whatever we attach to the drones, they are called payloads, and the payloads used for 3D mapping and imaging usually involves cameras called RGBD, that is red, green, and blue with depth sensing capabilities, and multispectral cameras. Along with that, we also use something called LiDAR payloads. LiDAR stands for light detection and ranging, where pulses of thousands of pulses of laser lights or even different types of lights are produced in every second, and depending upon that, images are created. Images are created. And during the drone-based 3D mapping and imaging, the ground is photographed several times. The photographs are taken from different angles, different heights, different trajectories, everything depending upon how the image is required at the end. If it's a sculpture, if it's an object, if it's just a flat map, but you want a 3D image, depending upon that, it's done. And you will be taking a lot of overlapping photos. Photos will have overlap of 80 to 90%, so that at the end, when you get the output result, to create a 3D map, you need to have a lot of information in the sense that you need to have the depth, you need to have the proper geo coordinates and every such thing, and the final 3D map output which you get will be rife with information of with the angle the photos are taken. You can just scroll around and see in every single angle of the 3D map. And ultimately, whatever the data is acquired during this process, during with the payloads of let's say RGB cameras or multispectral or LiDAR payloads, it will be put into a photogrammetry software. In case of LiDAR, you can directly take the output, but in case of other cameras or other payloads, you have to put it to a software called photogrammetry. Photogrammetry is a technique, and ultimately, the 3D images you get will be the final output, and you will get in a different types of output called 3D point cloud or orthomosaic outputs. Now let's see a video of the Christ the Redeemer statue over in Rio de Janeiro, how they do the 3D mapping of it.
The Ariane Scout is a quad rotor. I just click on the map telling it where I want it to go, and it'll just go there. I have the ability to create a target for the camera to look at. If I fly around in a circle, it'll keep that target in the camera at all times.
The way our software works is it's using the similar techniques that humans use when they use their two eyes to perceive their world in 3D. But instead of using only two eyes or two cameras, we are using thousands of images captured by a drone to combine these all together to have a consistent 3D model.
So as you saw in the video, this is done using normal cameras, that is RGB depth sensor cameras, or the multispectral. Here they have not used multispectral camera. They have taken a lot of photos, thousands of photos in fact, and later on they were processed in a photogrammetry software. And you can see the person explaining in the video. How they do is they have to take a lot of photos in different angles. How our eyes work is we watch in both eyes so that we get the depth perception, how far an object is, how near an object is, every such thing. So that in every photo they take, it is geotagged. And if you take thousands of photos and overlapping photos, you can get the depth, and everything is processed in a photogrammetry software. And photogrammetry is a technique. We'll be seeing what it is. This is in this video, we will see a company called Skydio. That's a US based company. They use artificial intelligence to do a 3D scan of a bridge, and it's an amazing use case. Let's have a watch it. This is a pretty awesome thing that they have done. They have utilized the technology of artificial intelligence, and the drone is flying autonomously to places that's actually, it takes a lot of time to go under the bridge. You have to use a boat or any other means of transportation, or you can just suspend a person through the air using scaffolding and harness and everything. Instead of that, a drone can do it in a matter of hours. And how the way it does the 3D imaging, it uses the photogrammetry techniques, and even it uses all the other payloads like RGB depth sensor cameras and everything. And the final output, as you can see, is pretty awesome. Okay, so now we'll see what photogrammetry is. Okay, so photogrammetry, it's basically a technique. It's not a technology, it's a technique. Here, a drone captures a large number of high resolution photos. So it takes a large number of photos of area, of a structure, or of an object, and it takes from different vantage points or different angles, so that it can get a clear cut view, like how you can go and you see a sculpture or any object for that matter, you rotate it in your hand to see how the shape is. The same way the drone does it, but with the camera it takes a lot of photos, and those photos ultimately they process it. The process, how they process it is they put it to a photogrammetry software. In that software, each and every information is already stored once you do the data acquisition. When you're taking the photo is taken in such that it's geotagged with latitude, longitude, even the height at which the angle is taken, all the details of the camera, the aperture setting, how much the light is taken, everything is stored there. So the photogrammetry software, when it's getting all these parameters, it will create a 3D model object. Even the lighting will be on point, and you will get something called 3D point cloud. 3D point cloud is, I think you've seen in a lot of movies where they show a 3D image and there will be a lot of points in that. Those are called 3D point cloud. 3D point cloud, if you go on each point cloud, you will get, it will show the information of having what and all images are taken over there. That's what a 3D point cloud is. And photogrammetry is basically done using payloads of normal cameras even, or RGB depth cameras and multispectral cameras. So, okay, so multispectral cameras are the cameras that take information from different wavelengths. Light has different wavelengths, and the multispectral cameras capture each and every information from different wavelengths. That's what they do. And this photogrammetry technique, it's been here for a while now, and they have employed it to drones and this 3D mapping and imaging. It's pretty cost effective, because if you have a very good drone and a very good camera in it, you can just take photos, you can do 3D imaging. You just have to have the photogrammetry software. Software is a bit on the expensive side, but even then it is cost effective rather than conventional methods where you have to do before, how they used to use aircrafts, or even you have to suspend yourself in the air, putting the scaffolding harness and everything. So how photogrammetry is done using RGB depth cameras, let's have a look at this video. There's a company called Vintra. They basically do aerial mapping and survey. They produce 3D maps at the end as well. In the world, they are one of the top companies. Here they are doing a 3D map of mine. So let's have a watch it. Here, the 3D mapping is done using a multispectral camera. Let's have a look.
To create a 3D NDVI point cloud from a commercial camera mounted on a drone is a challenge, but for many years we have had that idea. And now we see the need to bridge the potential of 3D and the power of multispectral images on an industry that traditionally uses only 2D index maps like NDVI. As humans, we have become extremely good at making decisions based on how we see the world as a combination of red, green and blue light waves. But there is much more beyond. Light information that we can't see with our naked eyes, but that still interacts with the vegetation and can tell us more about their health. The industry has already access to point clouds made from RGB images, datasets where they can take measurements in both 2D and 3D. Now at Pix4D, we've explored how to combine information from the individual bands, such as red and near-infrared. Combining the information from these individual bands, we get access to a whole new dimension of information. Vegetation indices, like NDVI, that can now be understood in their natural habitat in 3D. Thanks to this exploratory project, we developed the proof of concept behind this technology. Now is the time to explore where this can take research, business and industry.
Okay, so Pix4D is a photogrammetry software company. It's the leading company right now. And whatever mapping, survey, 3D mapping, 2D mapping, everything, all the experts all over the world prefer Pix4D. It's a pioneer right now. And right here in this video, you could see using a multispectral camera, they did a NDVI format, ultimately a 3D map of NDVI. So this right here, what the multispectral cameras capture images that are even not visible to the naked eye. They capture images from the light spectrum that is not at all visible to the our naked eye, even infrared, ultraviolet, all those light spectrum. But when you get the output, it usually is a 2D output. Pix4D, they have utilized those outputs, and using the photogrammetry techniques, the software is giving out a 3D output. You can even map a tree. You can 3D map a tree, I'm sorry. And when you do that, you can go ahead and see how the health of the tree, you can monitor each and every day if you keep on doing the 3D maps at regular intervals. The health of the tree and where it needs attention, and this can be done across acres of land for different vegetation. This is a groundbreaking technology going on. Okay, so these are some of the photogrammetry softwares you people can try out. So there are a lot of free softwares over there and a lot of paid softwares as well. You just have to register to it. Drone Deploy is a popular free software. They give 15 days of trial time for mapping. Even you can do 3D mapping with that. Pix4D is like I told you, and Agisoft is one of the popular software used in GIS community as well as the mapping community. Precision Hawk 3D, a lot of professionals use this. And Open Drone Map photogrammetry software, that's just like open source. Anyone can use it. And these are some of the popular softwares. If you want, you guys can note it down. So let's come to LiDAR. LiDAR payload is actually a expensive payload when it comes to it, but the applications with what you can do from a LiDAR is pretty amazing. LiDAR stands for light detection and ranging. It is a remote sensing method which uses pulsated laser light. It measure the ranges on the earth. So if you use a LiDAR, you can also do obstacle avoidance as such. The Tesla cars basically use LiDARs as sensors. so that they can navigate autonomously without hitting any obstacles. The same technology is used for 3D mapping over here. It also uses different lights. It sometimes uses visible lights, ultraviolet, or even near infrared lights. It depends upon the application that you are going to use for. But majorly speaking, for mapping and all, they use laser lights, laser light oriented LiDAR payloads. And LiDAR scanners are so powerful, they can capture hundreds of square kilometers in a single day. They have a huge range, and in 1 square meters, they can get up to 80 points, 80 points of information in 1 square meter. That's a very detailed image, be it a model or a landscape. It can create amazing detailed oriented 3D models. And whatever you get, the output from the LiDAR payloads are direct. You don't have to use a photogrammetric correction software. You can use only LiDAR correction softwares, though those are different to photogrammetry and the techniques are different. And basically, it will be strife with information where you don't have to give a lot of corrections, worry about a lot of parameters of height, depth, and such. LiDARs have such capability that they can even pierce through, dense canopy, vegetation. So if you want to create a bare structure, 3D map that's having a lot of, weeds or trees and such, you can do that as well. It can totally ignore that and just have a perfect 3D map of the ground. So this is one of the best use cases of LiDAR. Although it has been here since the 1970s, they used to use this in the aircraft. Now LiDAR payloads have shrinked in size. You can say that they have developed technologies in such a way that you can just employ it on attached to a drone, even a small drone for that matter, and use it pretty much anywhere. So let's watch a video where a LiDAR does the mapping, 3D mapping. Phoenix Aerial Systems is one of the top companies in the world who has been doing lidar-based 3D mapping. They have their own lidar payloads. You could see a circular thing that was attached to the belly of the drone. That's the lidar payload over there. That was a hexacopter drone, by the way. It is from DJI Metris 600. And you could see the real-time output that the lidar system produced. You got a 3D point cloud output directly uh, without any post processing. You can do the changes. You can have a different type of parameter based on the parameters. You can have different types of outputs. You can have the bare ground, or even with the vegetation you can have it. That's the accuracy of the lidars. That's how it is. So that these are the capabilities of 3D mapping and imaging right now in the drone industry, with different types of payloads, different types of techniques. This is employed throughout the world, and this is a pretty amazing breakthrough with the drone, because in the next industrial revolution, that is industry 4.0, it is basically robotics, automation, and drone is playing a huge part in it. You can go mobile anywhere in the world. Just you should have a drone and a payload for it, and you can do all the things. When it comes to drones, it starts from Earth and even it has reached to space. Now, even in Mars, we could see the Ingenuity rover flying a drone over there. That's how it is. Amazing drones are, and in the area of GIS or 3D mapping, even here drones are playing a huge role. And when it comes to 3D mapping and imaging, the applications are enormous. We have mentioned some of them here, where you can do mapping, cartography, where you can put maps. You can do transport planning, oil and gas exploration. You can even do volumetric analysis with with having the payload. You need to have just the right amount of technicians, proper technicians along with you, depending upon what the project is, or what type of application you are going to use it for. These are some of the applications which is popularly used throughout the world. Forestry management and planning, you can do that. Flood modeling, you can see the areas which will be flooded. The pollution modeling, even with 3D mapping, as you can have multispectral cameras that takes images in different wavelengths, you can actually see where pollution is, dense or less and everything. You can do mapping, cartography, where you can plan out maps. Urban planning can be done. That's not a big thing. We can actually see civil engineers standing in the side of the road holding telescopes and scales and everything. With the drones, their jobs are minimized, and it's very pretty helpful for them as well. The coastline management can be done. Transport planning is done. Oil and gas exploration, that's amazing use case, especially oil and gas. As far as we know, we can only get it in the deserts, or in the middle of the sea. Going through that through different transport means, it's a hassle. You need to have a huge team. Just with drones and all these techniques and technology, you can just fly a drone over there, get the information, get the data, if it's feasible or not, with the less loss, lot less time and money, and it can be done very efficiently as well. So these are the major applications that's happening. Now I would like to give it to Mr. Praveen, who will be talking about, who will be taking over from now.
Thank you, Mr. Abhilash. So when it comes to the career opportunities in the drone industry, we see a wide applications that I earlier discussed in this webinar. So when we come to the wide applications that we are looking at, and due to which it requires a lot of pilots and other technicians and development and design of drones, and it's quite a lot of people that is required for this industry. So we have a lot of segments that are there. So we have actually displayed here. We have the fleet operations. We have the design and development. We require the software developers for them. We need electronics and communication engineers for managing the electrical parts of the drones. We need maintenance engineers who can maintain these drones. And when it comes to the electronics, like who are well versed in data analysis, communications engineer, systems integration engineer, who have done even VLSI based technology, who are trained and worked on these kind of segments. So the industry is actually pulling. So the drone industry is not limited to just aeronautical or to any avionics based engineering professionals. So it also draws people from the mechanical division, from the electronics and communication, from the EEE division, from the computer science and information science division. So it is a multiple layer of engineers working for the industry to get these drones out and achieve and implement the applications. So when it comes to the drone fleet operations, you need a drone pilot. Along with that, you need a drone co-pilot. So you also need a drone test pilot to test the drones once they are being manufactured, and when the R&D is completed to test any specific component, you need the drone test pilot for them. In order to get drone pilots and co-pilots, you need a trainer who can train them on these drones so that they can later be deployed for or as a drone pilot. So you need the UTM technician as well for the maintenance and for on-spot troubleshooting and application-based running. So you need a technician there as well. So what are the salary packages that we look into these people is, for a drone pilot right now in the industry standard is about 20,000 upwards. And we are looking at people who have a very good knowledge in about drones, who have technical knowledge about flying these drones, maintaining these drones, and who have the capacity and ability to understand if what are the challenges that they may face in the environment, because climate and weather is one that we cannot control, but remaining can be controlled. How can you make positive judgments and likely fly these drones? So that is how tasking a drone pilot has. And so what is the pay scale is between 20,000 and upwards. And also what are the other skill sets that we have, and you can negotiate with the HR depending on that. And for a co-pilot, also the same thing, because a co-pilot and a pilot is not different. Both of them need to work hand in hand to get the operations completed. And what is the pay scale we are looking at is between 15,000 to upwards to 25,000. So that is the amount that we are looking at them. So test pilots is slightly larger. We look at them at around the initial salary is about 40,000 plus. And it also depends. See, when we say a test pilot is because there is standard that is there in the industry that they should have a minimum of 500 hours of flying. It is not 500 days or number of days. It is the hours that we are looking at, just like the commercial aircrafts. So if in case they have more than 500 hours of flying, they can really have they can take up this position as a test pilot. And a drone pilot trainer should have a minimum of flying a drone and being a test pilot. Conclusively, they should have more than 1,000 plus hours and the ability and the knowledge to impart this training to them, because it is just not flying. They have to impart the knowledge of understanding at what particular kind of scenario, what are the other what do you say, these maneuvers that you need to do to take these drones and how to handle them and how to fly them in certain conditions. So they have to impart these kind of knowledges. So when it comes to the design and development, structural engineers are required who are able to do designs on CAD, on CAM, on AutoCADs, on Maya, Fusion 360s, like these. So ANSYS and CATIA based softwares. And once they have done the structural design, they can even do the stress test and analysis and doing a complete simulation through various modules and get the results and try to find a more stable and a more strong structural design. And we have a lot of other fabrication division takes into place. So the fabricators, whatever, depending on the designs that have been given by the designers and the CAD engineers, they can make up all of these designs as well. So there again, we come into composite fabricators. So their salaries are anywhere between 25,000 and upwards because of their unique skill of building the entire product. And when it comes to software engineers, they are the one of the primary reasons for the avionics. So avionics on board requires, so for example, if you're looking at the flight controller, it requires a firmware, the ROM is required, you need to custom build or you need to build from scratch. So there's a wide scope for software engineers. Apart from the firmware that is used on the flight controller, the application also requires software engineers who can work on the application so that the UI interface to the user as well as the operation machine learning and the artificial intelligence can take place. So all of this requires software engineers, and during the post processing also we require engineers to work on them with the software that has been developed for that particular application. So when we come for the electrical engineers, they should be a very good understand. They should have a very sound knowledge in the electrical segment as to understand how much will be the charging, how much will this battery, if in case a particular battery, like for example, if in case you take a lithium polymer battery, what is the charging duration, what is the requirement. So depending on the drone's payload, okay, so a drone is basically designed based on its payload. So requirement of a payload and what is the challenges and its application, based on that the entire drone is built. So if in case if it's for mapping, and we always say the mapping payload is majorly a camera. So that could weigh anyways between from 230 grams upwards to 800 grams or 1 kilo. So a drone is built around it. So a drone that is able to carry a payload of 1 kilogram is being designed. And if in case you're doing it for long endurances, then you will be designing a drone which is like a fixed wing or a hybrid drone. And so the entire application change, depending on the application, the entire drone build or the design is changed. And so depending on these design changes, the engineer, the battery engineer or the specialist comes into play to get an optimal, or depending on the requirement, he designs the battery or the fuel or the other avionics and all of these. Depending on the requirement, they build the drone batteries for them. And wire harness engineers are super critical because wire management is super important, because multiple wires will be there. It is like literally like a pack of noodles. That is what I can say. If in case you do not do wire management, you will never know which wires these are connected to which of the avionics. And now if in case one of the wire is shorted or something, it can catch fire. If in case you have not done wire management, the entire set of wires can get burnt due to the short circuit. So a lot of idea of streamlining and wire management is super critical when building a drone. When it comes to assembling and maintenance, they are the backbones of the entire fleet operations. Trust me, without them, the fleet operations the drone operations and the fleet can never work. Because of these hardworking guys, it is why the drones are safe in the sky. So when it comes to the assembly, if in case it's a brand new drone or something like that, then they build it together, they fabricate them and make them perfectly, and they build it and give it to the test pilot to test the aircraft. When in every drone that goes to the field and when they come back, the maintenance guys maintain these drones. They check for the cycles of certain consumable equipment, like for example, the propellers, the motors, the ESCs, and other parts that are used for the drone. Have they run through the entire cycles? If in case the cycle is completed, these guys change those avionics, and they get the drone back in fit condition to fly more number of flight hours. So these guys are super critical for the entire operations. When it comes to electronics, these guys make the larger drone into, I mean, the entire motherboard, or maybe the entire avionics into a compressible format, and so that they can put it into the drone. And because when we say a lot of avionics, is because of many things go into the drone. So these system engineers, integration engineers come into play to uh, put the entire avionics in a compact and in a small place so that it is not dragging around the different places. So it has a very good, they have the backbones in getting the entire drone compressed into that entire drone build. And data analysts are super critical to get the data, whatever has been acquired during the entire mapping or any other applications. They analyze the data and process the entire data. So communication engineers are the engineers who are looking into the communications between the drone and the ground control station and the avionics that goes into it. And different protocols are there, some different bands of communications are used, maybe Wi-Fi, Bluetooth, GSM based or satellite, SATCOM based communications. So multiple platforms are used for communication. So we need communication engineers to do all of this. So the career opportunities when it comes to drone is very wide and open scope. And anyone in the engineering segment can definitely work in the drone segment. It is not just limited to an aeronautical engineer, but it is open to mechanical, civil, to be it computer science, be it information technology, be it the other electrical and communications. All of these engineers can definitely work in the industry. Next slide, please. So about JMA. So JMA is founded by Mr. Leo Peter Charles, and he's the managing director of Jane Aerospace. And it was started in December 2019. And ever since then, we have been the forefront leaders in ecospace building for drone here in India. So we consult for companies, we consult for governments, be it for application based or be it for other government related projects. We are one of the forefront leaders in accomplishing this. So we work with many companies in the drone industry. We scale up these companies. We also aid them in their projects, and we also consult them for how this project can be completed, how can it be taken forward, how this project can be successful. And we also work with government and how government can work with drones for their related issues or for their projects. Very good example that we could say is during the COVID when the lockdown happened. In the first lockdown, me, Mr. Leo, Mr. Ritesh, and Jane Aerospace were deployed in hotspots in Bangalore, and we were flying drones. So we were using drones to monitor survey for surveillance purposes for the civil for the city police of Bangalore, and we flew the drones in very hot spots. So when we say COVID hotspots, is like the police personnel did not want to go into those kind of hotspots, and we flew drones to do announcements. So we attached a microphone on board, and we flew a drone, and we were announcing, saying people to be aware of the certain conditions, to avoid loitering around. If in case we saw people being on the buildings rooftops, they were, the most interesting thing is like when we were doing the surveillance, we also see a couple of people on the rooftops playing carom board, and they're jumping between buildings, and they were all having a good chatter even though the roads were empty. So since we were in the sky, we were able to monitor all of this and further notices to all these people, and PA based announcements were made to avoid all of this so that the spread of COVID is limited. And Jane Aerospace also worked with wildlife department of Karnataka to monitor during this lockdown. We saw a lot of intruders or poachers inside the Banargata forest and Pandipur forest trying to poach wildlife animals. So when they saw the presence of drones, it was retardant for them. So they did not want to go and get into trouble. So it was a major milestone for Jane Aerospace. We have worked with the Orissa government as well, where Mr. Ritesh and Mr. Leo Peter Charles had traveled 1,200 kilometers on road to Orissa to aid them in operations out there for sanitizing and public announcements there in Orissa. So even though we were in the lockdown, we were able to still accomplish. Now, since the lockdown has been lifted, post lockdown services were rendered. So again, we were working with other government related agencies. So Jane Aerospace is tirelessly working in two major fronts. One is the pilot training segment, and also with the consultation and scaling up businesses. So we also provide pilot training here in Jane Aerospace so that we skill engineers and they go and work in the industry rather than without. See, what we basically understand is that the industry requires skilled manpower. So Space is tirelessly working in that segment as well, apart from the consultation. So we'll go to the next segment, next slide. So our services, so we come up with pilot training as well as with consultation. And what we do in consultation is we do infrastructure consultation. We provide skilled manpower and support to client and client-based training. We do business consultation. We also help in investments. We help in government liaising. We also help companies do their QCI compliances. We support heavily on R&D, and we also have our own airfield wherein multiple companies come and test their aircrafts there, all their drones, their equipments. So top leading drone companies in and around Karnataka come and test their drones there. We also help in international collaboration for Indian investors to bring in the international tech into India and make India the global superpower of drones. The next slide. So these are our awesome clients that we have working with and partnered with. We have EVA, we have the Odisha government, we have Asteri Aerospace, General Aeronautics, OS. OS is the Arnav Unmanned Air Systems. We have Red Wing Labs, Absolute Composites, Throttle Aerospace, Usnatech, Indrones, Garuda Aerospace, Hela, Centurion University also is partnered with us, and we have the Float Nomos. So these are our valuable customers, clients, and our partners. So EVA is an international company that is we are right now working with to deploy drone in what do you say, like it's a package system wherein they just drop in a package and the drone delivers and comes back. It's a drone hub kind of services that has been provided by EVA. And Aster Aerospace is one of the leaders in mapping and survey here in India. We also have OS, and we also have Throttle Aerospace, which is working in these four fronts for government of India. And we have OS as well, working in other four fronts in mapping, technology, and manufacturers of drones for made in India drones. So there's multiple partners that we are working, and this is creating an ecospace, and this ecospace can be very powerful here in India, scaling up drone industry in various forefronts. And as I said earlier, we have 220 plus drone applications, and we have 37 such industries that are employing drones into the service to their services. So manufacturers, drone as a service, and drone pilots are all the critical elements for the drone industry to grow here in India. We'll have the next slide, please. So we have a very interesting program called as Flight 100. And Flight 100 is actually an entrepreneur-based program where we guide them, and we mentor them for a period of 1 year, and they will be taught on different forefronts as to what to be an entrepreneur, what are the challenges that they'll be facing, what is the things that you need to do in order to run an establishment, in terms of registering, in terms of running, and how you can employ people, how to procure projects, and how to conduct projects in a very systematic and a streamlined way so that you make profits. And end of the day, it is all about the money, but still how to go about that money, how to get that money is what we will train you to be a successful entrepreneur. So the classes will cover classes on drones, the AIs, the applications, the softwares, the integration of the solutions, and we'll be introducing to the setup, how to setting up your company, where you can set up, because it is geographical, as well as the different laws that have been passed in different states for industries, and what is the best way you can get all of those subsidiaries, and all of those will help you with those. In financial education, how to manage your finance, because we majorly see a lot of companies shutting down because of their because of the knowledge that they don't have in the financial management. They do not able to manage their funds, the funds that come in and how the funds that go out, and their inventory management to their administrative management. So we will help you in all of those as well. And when it comes to the investment and fundraising, that is a super critical part to scale up your business. And we will help you with angel investors and other sources from the government, and what are the subsidies that you can get to scale your business. And we'll give you masterclass from the experts. All the classes will be taken by the industry experts on their domains. So it from the HR division to the government licensing, registrations, to running a financial how to run your financial assessment assets and your assessments on those, from the point of getting procurements to deployments and controlling your projects and delivering your projects. All of this will be mentored by industry experts. The next slide. So Mr. Leo Peter Stiles always keeps telling us this drone applications are limited by human imagination. So we strongly believe that, because as I said earlier, the 220 plus application is only brought up by the imagination of humans. And as they thought, when they can bring in the tech into the drone and let the drone do the work, and the drone had a new application. So likewise, we thought, why don't we put a PA system on a drone, and the new application came up where drones were making announcements. So likewise, it is just limited by a human imagination. So thank you for joining us for this wonderful webinar. And if in case you have any questions, you can shoot it out to us. We will answer them all up, depending on me and Mr. Abhilash will be here to answer all your questions. Thank you, one and all.
Thank you, sir. Thank you for your valuable words. Thankfulness is the beginning of gratitude and sign of noble. I would like to call upon Professor T. Banu ma'am, Assistant Professor at Nehru Institute of Technology, to deliver oaths of thanks.
It's my privilege to give the vote of thanks on this occasion. I thank Dr. P. Krishnadas, Managing Trustee, Nehru Group of Institutions, and Dr. P. Krishna Kumar, CEO and Secretary, Nehru Group of Institutions, and the Honorable Principal, Dr. M. Shivaraja sir, and Professor S. Bhairavi, Head of Analytical Department. And I really thank the two speakers, Mr. Praveen Vishwanath sir and Mr. Abhilash sir, to share their valuable knowledge with us with their busy schedule. Thanks for the wonderful session. Thank you all once again, the faculty members, students, as well as who are coordinated for the successful completion of this event. Thank you all.
So we have a Q&A session. If anyone has your Q&As, you can throw it at us and we will shoot out the answers for you. We have a couple of them on the chat box. Let me lift them up for you, and we will go one by one. So Ms. Deepanjali had asked about the more number of 3D images, the more accurate we can judge the place. So could you just enlighten on us on that question, Ms. Deepanjali, so that we could answer this for you?
Mr. Pravesh, I think Mihir Jain is raising his hand.
Please go ahead, Ms. Mihir Jain.
Hi, good morning. Thank you for the wonderful session and the information. As a guy who's just left the filmmaking industry and wants to enter the drone industry, what steps would you suggest someone like me who's not in any way an engineer at all, but who does have an interest in technology and has a good knack of learning things? How would you suggest I go about something like this?
So right now we are looking at a lot of cinematographers in the drone industry. We have our cinematographer who works for multiple companies, for example, like National Geography Channel, There's even the Man versus Wild was shot on drone. Our cinematographer has been making a lot of advancement in this. He's using drones for all of this, and he's quite good at it as well. So when it comes to in terms of career opportunities, it is very wide, and it is not limited to just cinematography. Now the what we have seen with in association with Karnataka for Photographers Association is that apart from the cinematography that they use for weddings or even for the movies, they're also jumped into the 3D mapping and surveillances as well. So they are able to data capture, they're able to render their services for the archaeological department because they are able to get high resolution data or imaging capture from these architectural or these monuments, and they're able to feed those data into to create videos or to make 3D renders of them for multiple purposes. It could even be for map, and it could be for promotional activities or something like that. So what we see is that if in case it's weddings or something like that, we see from anywhere between 30,000 and upwards, depending on the duration of the video that is given. When it comes to cinemas, it is quite larger. The amount is quite huge, depending on the action sequences or how mellow the video needs to be to introduce the introductions. So I did not go about it much, but the industry is very wide and open for cinematographers. That is what I could see. Because it's just not limited to cinematography, they can easily jump into other segments and give their solutions or their services for other industries as well.
All right, thank you.
Anyone has any other questions? We are open for them. If it's all, then we can wrap it up. By 3D capturing, we have a question from Sibin. So by 3D capturing, like what done is Iron Bridge, whether we can also capture flight designs. I guess Mr. Abhilash can take this question for you.
Yeah. So I'm not clear with the question. By 3D capturing like that done in Iron Bridge, whether we can also capture flight designs. If you are meaning flight data, yeah, we'll have flight data. So all drones will have something called a telemetry. All the flight data will be stored. If I'm wrong, can you please correct it? I'm not able to understand the question.
Mr. Sibin, you can unmute yourself and you can have a chat with us.
Sir, hello.
Yeah, go ahead, Mr.
Sir, by that 3D capturing, whether we can also capture that image in flights?
In aircrafts, you mean?
Air capture.
Aircrafts, I don't think so you can do that because you will have to go very close to the bridge, and you need to have a helicopter at least, to go below the bridge. It's very difficult to do that. It would be advised, and it would be smart to go by a drone. Theoretically speaking, you can do it with the aircraft, but you need to go very close to the bridge, and but going with the aircraft that close to the bridge is not possible, practically speaking.
Okay, thank you.
So, Abhilash, that question was like, can we do the same design for flights? The Skydio has done this with what do you mean? The aircrafts which carries mini satellites. It's in their website, and you can go through it actually.
If that is all, we would like to wrap up this session. And right now, if you check in your chat box, you will see a link to which we would love to hear your feedback on this entire webinar. And this will also enable us to send you your certificates. So kindly fill in the details to us so that we could make our webinars more interactive and more informative in the future. Your valuable feedbacks are super important to us so that we grow as well as we all grow together in the whole segment. Thank you one and all for the wonderful opportunity. I have my special thanks to the organizing facility, the faculty members of the institution, Nehru Institute of Technology, Coimbatore, for this wonderful day that you have given us to speak about the drone technology to your wonderful students out there. And we would like to jointly work in the future. And you can get in touch to us to either one of Ms. Kaneet or to Mr. Prajwal, and we will take it forward from there. Thank you one and all for joining us, and it's an absolute pleasure to having you all today. Thank you. Bye-bye.